In this series, we're looking at 4 fundamental prerequisites for comprehending texts and how to go about teaching those to students. We are going to learn in this series that these are being approached incorrectly in our reading classrooms today. And we're going to learn what we need to be doing differently in order for our children to grow up to be readers. The 4 prerequisites for reading that we're going to be looking at are phonics, grammatical fluency, world knowledge, and knowledge of the keros, or whole context of the text. This is not the typical list that you're going to encounter out there in education schools and education pundit land for the prerequisites for reading. That's because our reading instruction today is dominated by folk theories, not wedded to and proceeding from our contemporary scientific understandings of language acquisition. Okay, in this talk we're going to look at phonics and reading comprehension. This is the one bright spot in our reading instruction, an area where practice has finally sort of caught up to scientific understanding. However, it's taken us a while to get there. In the middle of the last century, we were still using what is known as the look-say method for teaching kids to decode texts. This method was enshrined in such curricula as the Dick and Jane readers. The method was based on a now discredited behaviorist theory that saw language learning as repeated exposure to increasingly complex language stimuli paired with ostensive objects. In the case of the Dick and Jane readers, with illustrations. See Dick run. Dick runs fast. See how fast Dick runs. The theory of language learning by mere association of the stimulus and its object dates all the way back to St. Augustine, who wrote the following in his Confessions. When grown-ups named some object and at the same time turned toward it, I perceived this, and I grasped that the thing was signified by the sound they uttered, since they meant to point it out. In this way, little by little, I learnt to understand what things the words which I heard uttered in their respective places in various sentences signified. And once I got my tongue around these signs, I used them to express my wishes. Okay, that's St. Augustine. It's an intuitive theory, like the theory that moving objects use up their force until they stop. But like that theory, it's wrong. Look-say was a flawed approach because it was based on a false theory of how language was acquired. The fullest exposition of that flawed theory can be found in B.F. Skinner's Verbal Behavior, published in 1957. In 1959, Noam Chomsky, who has done more than anyone to create a true science of language learning, delivered a devastating blow to behaviorist theories of language learning in a seminal review of Skinner's book. Basically, Chomsky described aspects of language such as its embedded recursiveness and infinite generativity that, like jazz improvisation, cannot be explained solely on the basis of responses to stimuli. More about the Chomskyan revolution later. Toward the end of the last century, hundreds of thousands of educators around the country embraced something called whole language instruction. Proponents argued that it wasn't necessary to teach kids sound symbol correspondences because language was learned automatically in meaningful contexts. The idea was that one simply had to expose kids to meaningful language at their level, and the decoding stuff would take care of itself magically in the absence of explicit decoding instruction. Now, those states and school districts that adopted whole language approaches saw their reading scores fall precipitously. Education is given to such fads and to such disastrous results. The learning of Japanese kanji provides a useful hint about learning to read entirely based upon whole word recognition. That is the whole language approach. Japanese has not one but three phonetic writing systems: hiragana, katakana, and romanji. But it also has characters called kanji adapted from Chinese characters that stand for whole words. These have to be memorized individually. The average Japanese reader knows only about 2,000 kanji, far fewer than the number of spoken words that he or she knows, and far fewer than the total number in the language. One dictionary contains 85,000 kanji, though the usual number given for kanji is around 50,000. This is a serious problem. 85,000 kanji exist, but the average adult Japanese can only recognize about 2,000 of them. So, learning individual words, as in the whole language approach, is not ideal, is it? The Japanese who are forced by their writing system to learn to read much of their language in this way learn to read only a tiny fraction of the words in their language. That said, the analogy between learning kanji and whole word recognition isn't clean. Why? Well, consider this. Have a look at this sentence. Based on context and opening and closing graphemes and general knowledge of the spoken language, readers can recognize words. So, there are clues in written English not found in kanji, though most kanji are synthetic, that is, built up of other kanji, and these provide clues as well. A little knowledge of linguistic science would have prevented the debacle that was whole language. The best current scientific thinking is that language emerged some 50,000 to 70,000 years ago, though there's some current research that pushes that back. For many thousands of years, people learned to use spoken language without explicit instruction. However, writing is a relatively recent phenomenon. It's been around for only about 5,000 years. It emerged in Mesopotamia around 3000 BCE, in China around 1200 BCE, and in Mesoamerica around 600 BCE. Both the Luxay and whole language proponents fail to recognize that spoken language has been around long enough for brains to evolve specific, hardwired internal mechanisms for learning it automatically in the absence of explicit instruction. That's true of spoken language, but it's not true of writing. There is no evolved, dedicated internal mechanism in the brain specifically wired for decoding of written language as there is for spoken language. Instead, decoding of written symbols, graphemes like this or this, and associating them with meaningful speech sounds, phonemes like this, is most easily learned by kids from explicit instruction. Some children are good enough at pattern recognition and get enough exposure to grapheme-phoneme correspondences, or GPCs, to be able to learn to decode in the absence of explicit instruction in interpretation of those correspondences. Such decoding appropriates general pattern recognition abilities of the brain and puts them to this particular use. But even some of those kids, ones who learn to decode without explicit instruction, sometimes don't develop the automaticity needed for truly fluent reading. There is now no question about this. There is voluminous research showing that many, perhaps most students have to be taught phonics, sound symbol correspondences, explicitly if they are to learn to decode fluently. For excellent reviews of this research, see Diane McGinnis's Early Reading Instruction, What Science Really Tells Us About How to Teach Reading, published by the MIT Press, and Why Our Children Can't Read and What We Can Do About It, A Scientific Revolution in Reading, published by Simon & Schuster's Touchstone imprint. The Look-Say advocates got their ideas from simplistic behaviorist models of learning. But where did the whole language people get their crazy idea that one could learn language just by looking at whole words? Well, from listening at the keyholes of linguists. As often happens in education, professional educators had half heard and half understood something being said by scientists, and then they applied it in a crazy fashion. What they half heard was this, that linguists were saying that language is learned automatically. The part they missed, because they weren't listening carefully enough, is that the linguists were talking about spoken language, not written. The upshot. In order to be able to comprehend texts, there is a prerequisite, automaticity with regard to decoding of GPCs, of grapheme-phoneme correspondences. Where does one get this automaticity? Well, for many kids, from explicit phonics instruction. This is a lesson that we have learned. Classroom practice has caught up with the science. Almost all elementary schools now use successfully in the early years an explicit early phonics curriculum, typically as part of a balanced literacy program, unfortunately, and all the major basal reading programs in the U.S. have strong phonics components. That's the good news. For these other components that we're going to be looking at, the news is not so good. A couple of comments. The best way to approach this phonics thing is to do it all as a unit and get it over with at the very beginning. Seriously. Instead of having bits and pieces of phonics instruction scattered around through a reading program. One other note. Why do so many teachers persist in the crazy notion that most students can learn to read without explicit phonics instruction? Well, as I pointed out, some people can learn sitting on their parents' knee with a book in front of them to read based on general pattern recognition capabilities of the mind. Often those people who are extremely verbal as children grow up to be English teachers, and they say to themselves, well, I learned to read without learning phonics. But that's true of a very small percentage of our students. Most students need an explicit phonics component early on. Why? This is how their brains are constructed. There hasn't been enough time to develop a dedicated part of the brain for interpreting grapheme-phoneme correspondences, that is, for doing written language. So what's true of spoken language is not true of written. Okay, please like and subscribe. Watch the rest of the videos in this series on early reading instruction, and please check out the rest of the videos on my channel.